we want to do is find a particular solution to a differential equation. So far we've had the general solution, for example the integral of 4x dx. We use the power rule, x to the second over 2. We pull the constant out in front, so we have 2x squared plus c. This is called a general solution because we don't have one value of c, we have many values of c. However, we can also find what's called a particular solution from an initial condition. Suppose we're given, in this particular situation here, our function f is equal to 2x squared plus c, given that negative 210 is part of our solution curve. So we would have that f of x equals 2x squared plus c. If we replace x with negative 2, and we replace f of x, or y, with 10, we have this equation. So if we solve this, we would have 10 equals 2 times 4 plus c. 10 equals 8 plus c. So c here equals 2. This particular solution then would instead be f of x equals 2x squared plus, and now replace the value of c with 2. This would be a particular solution rather than a general solution. Let's have this problem given in a different way. Suppose the second derivative of some function is x plus 2. The first derivative at 0 is equal to 3, and the function value at 0 is negative 1. Can we find this original equation? So f double prime of x equal to x plus 2, so that means the second derivative with respect to x is equal to x plus 2. So if we would integrate, we would then have the first derivative of y with respect to x. If we integrate this, we get x squared over 2 plus 2x plus some constant c. This is a general solution, but we also know that the first derivative at 0 equals 3. So to find this, we replace this with a value of 3 will be equal to, we put a value of 0 in for x, so we have 0 squared over 2 plus 2 times 0 plus c. So c has a value of 3. So that means our first derivative would be of the form x squared over 2 plus 2x plus, and now c is replaced with 3. We can go a step farther. Now if we integrate the first derivative, we wind up with our function y. If we integrate x squared over 2, we have x cubed over 3, but we continue to hold on to the 2, plus 2x squared over 2 plus 3x plus a new c. However, because we know when x is 0, the y value is negative 1, we can replace y with negative 1 equals x cubed. We're putting 0 in for x. We have 0 cubed over 6 plus 0 squared plus 3 times 0 plus some constant c. So all these disappear, and we're left with c as a value of negative 1. So that means our final f equation, a particular solution, will be x cubed over 6 plus x squared plus 3x, and since c was equal to negative 1, we would wind up right here. A classical problem that we run into is called a vertical motion problem. The acceleration due to gravity is negative 32 feet per second squared. A ball is thrown vertically upward from the ground with an initial velocity of 56 feet per second. Find out how many seconds will the ball be going upward. Now acceleration is the same as the derivative of velocity with respect to t equals negative 32 feet per second. So if we integrate this, if we take the antiderivative, we're going to wind up the velocity is equal to negative 32t plus some constant c. But since we're given the initial velocity is 56 feet per second, if we replace velocity with 56 feet when t equals 0, we have our constant here, c, is equal to 56. So we can write the equation b equals negative 32 plus 56. Since we don't know how many seconds will the ball be going upward, please notice the velocity when it reaches its high point will be 0. So if we set the velocity equal to 0, and we solve this equation, putting 32t to the other side of the equation, dividing through, we have 56 over 32, or 28 over 16, or 14 over 8, or 7 over 4 seconds. So, after 1.75 seconds, the ball will be going upward. It will reach its high point.